On this image, you see how on the left hand of the plateau, because plateaus are always flat sedimentary rocks, we have all the layers of sequence. But since it cuts through a bunch of layers, if I were to look on the middle of this geologic feature, it looks like that the rock ended at a certain time. But since I know how the sequencing goes, I can infer that something happened to erode the entire top right half of this feature. The one exception to superposition is folding and faulting. Because, remember, superposition is the oldest stuff is always on the bottom. But if something is folded or faulted, they can be pushed above older rock. So, once again, folding are the bends in the crust from plate movement, and the faulting are breaks in the rock where movement occurred. And in some of these cases, the older rock is on top of younger rock, and they create offset layers. If you all remember that one assignment we did where we had to create those boxes with those faults that you colored and then cut, well, when you move those layers apart, some of them went above the other layers. So while you assume that the bottom's always the oldest, have to look at cases like that where things can be moved. And folds and faults can still occur after the horizontal layers are deposited. So these are usually some of the trickier parts of figuring out what came first, second, third, fourth, etc. So look at which of the layers are put down, where the fault could happen, and what might happen before and after. So again, it's a big puzzle, and you kind of have to figure this out, what came in what sequence. For these next 3 slides, we're going to do some of this together. So I would like you to get out a piece of paper and figure out on your own, put everything in order, and then pause this, and then play to see if you get it right. Happen for all 3 slides. You'll be doing a lab, which is just like this. You can do it at home, so it's not, that detailed. But if you can master this, then any of these problems will be fine. I also do expect to give you guys a quiz on this, a nice easy 10-point quiz. So if this seems easy to you, that should be fairly simple. So pause this, try this first one, see if you get it right. If so, then move on, and repeat the same steps for the next 2 slides after this one. Alright, so in dark blue, I'll put down the number next to which order that these rocks came. So C is number 1, because it's the one on the bottom. B is the second oldest, because it's on top of C, but below everything else. A is our third, because it's on top of B. But I do have to look at the fault and the intrusion, since the fault and the intrusion, so E and D, cut through A, B, and C. Those 2 have to be older. The next oldest is D, 4, because that cuts through all the 3 previous layers, so it has to be newer than that. But since it's broken by the fault, had to be older than the fault. Therefore, E is the newest event, number 5, because it cuts through everything. On some of the examples, if there's a 6 line, if you look at the surface, it is not flat, so erosion, and I'm sorry for the bad handwriting, but we do what we can, would be number 6 if you so choose so. If you got this right, understand it, move on to the next one, try it, and then hit play to listen to the correct answers. Okay, so for the second one, because it's on the bottom, this layer P is the oldest layer, and that's a horrible one. So let me write that again. And it's a bit better. All right. So the next layer would be K. That's our second one because it's above P. But since R has cut through it, R has to be newer than that. M is our third. Same principles as before. S is the fourth. And X over here is the fifth. Now we have to take a look at either the erosion A or at R, our intrusion. When intrusions come through, the lava doesn't just stop at those points, it has to flow over. The fact that most intrusions are extrusive, it would have to go above it. So R is our number 6. Therefore, erosion A is our 7, because the erosion has actually destroyed some of the igneous intrusion. And then B is 8, J is 9, and F is 10. So most of it is fairly simple. But again, it's going to be the erosions, tilting, intrusions, foldings, which would be difficult. Alright, so this last one here is fairly complex. So try to figure this out. If you miss a step or two, that is fine. But try to figure out most in order. Some that we can't know what happened first or second. But I will write on the top, from left to right, the oldest to the youngest in white because it's easier to read on this page. So try these. There's approximately 16 steps in this one, maybe more. And then I will then hit play again and listen to the answers. Alright, so the first thing we have would be E. It's the one on the bottom, and everything else cuts through it. Next one would be an actual unconformity, which I would just put down at U and C, unconformity, because there is a slight wavy line in between E and G. Then next would be layer G, followed by L, then C. After L and C, you can see that they are no longer flat, so they were tilted. So we have our tilt, and then we have our fault H, because H breaks up all those layers. Since the fault extends to part of C but doesn't go into M, we have another unconformity. Then we have our M, and then our D. That yellow brick limestone area, that is letter J. But you notice, now we have our intrusion of A. Since it cuts through E through J but not into N, A had to come next. But since A doesn't extend any further and it should have gone above J, we have once again another unconformity. Then above the unconformity, we have N, K, B. After B, we have another unconformity, which probably involves the tilting, so you just leave unconformity. And then we end with F. If you notice, F isn't continuous. If you look at the surface, see how it dips down and cuts into K. So at the end, there is surface erosion. So that's this one in every step. Some parts, usually on the pictures, you have better pronounced unconformities. If you miss the unconformity between E and G and C and M, I get that. Don't worry about that. On the lab and on other assignments, it'll be more pronounced. But this is as complex as you'll see any questions I ever give you. On the tests and on regions, will not be anything this complicated. So if you got through most of this one, you're good. And this ends day 1 of the notes. Tomorrow you will be getting a lab that is basically just this all over again. But the symbols on this map, so the yellowish J area would be limestone. K would probably be a shale. F is a sandstone. So once again, these symbols match the symbols in your reference table. You have to use that.